Okay, girls, today me and Max are going to tell you about counting and discrete mathematics. So the counting principle says if event A has X outcomes and event B has Y outcomes, then if you want to figure out how many outcomes both A and B have together, you multiply X and Y together. So the event A and B is going to have X times Y outcomes. So for example, if we're going to make like an ice cream sundae or something, and A is the ice cream flavor and B is the ice cream topping. If there's 3 flavors, chocolate, vanilla, and strawberry, and 4 toppings, whipped cream, cherries, nuts, caramel sauce, then there's going to be 3 times 4, or 12 different ice cream with topping choices. So that's 1 ice cream with 1 topping. There's 12 different things that you could choose. Okay, another example. Let's say we're looking at a lock combination, and it's made up of 3 one-digit numbers and then 3 letters. So how many different combinations are going to be possible? Well, if you think about the numbers, there's 10 possibilities for the first number, 10 possibilities for the second number, 10 possibilities for the third number. And then the letters, there's going to be 26 possibilities for each one of the letters. So that's how many different values there could be for each one of those places. But then we would multiply all of those numbers together to get the total number of different combinations that are possible. So when we do that, we'd have 10 to the third times 26 to the third, which turns out to be like 17,576,000 different combinations. That's crazy. Okay, now let's talk quickly about factorials. So remember, factorial is what we call the thing where we have a number with an exclamation point behind it. And to calculate a factorial, multiply the number by every whole number that's less than the original number. So quickly, 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1. So the thing about factorials is sometimes when we're doing counting methods, we want to divide some factorials together. And so we're going to look to cancel out or divide out common factorials from the numerator and the denominator. Okay, so here we go. Let's do it. Let's say we wanted to divide 12 factorial by 3 factorial times 7 factorial. Okay, so if we wanted to do that, then we would say 12 factorial is, we would multiply it out till we got down to the biggest factorial, which is 7 factorial. So 12 times 11 times 10 times 9 times 8 times 7 factorial. And then on the bottom, I'm just going to leave that 3 factorial times 7 factorial right now. Dude, that's not cool. Okay, so where were we? We were going to cancel out my 7 factorials just like this. And that's going to leave me with 12 times 11 times 10 times 9 times 8. And then on the bottom, we still had 3 factorial. That's 3 times 2 times 1. And so now what we would try to do is try to divide some things out. So for example, 3 goes into 12 4 times. So we'd make that 4, and then those would divide out. And like 2 divides into 10 5 times or something. And then we'd multiply 4 times 11 times 5 times 9 times 8. And it's still this really big number, 15,840. Holy cow! So now let's talk about permutations. So remember, permutation helps us figure out how many arrangements there are of several items, like letters, or people, or food, whatever. So, for example, if I've got 3 letters, the first 3 letters you're going to learn, A, B, and C. And if I want to know how many different words I can make with those 3 letters, I could list all the possibilities. So the letters A, B, and C could be ABC, ACB, BAC, BCA, CAB, or CBA. So there's like 6 different words I could make with those 3 letters. And we say that each word is a different permutation of the same 3 letters. Okay, so let's look at the formula. So we've seen this before. We say NPR, and N is how many objects I had in total to begin with, and R represents how many objects I'm putting in each group. And we would find the permutation NPR, or sometimes we say NPermR, by finding n factorial and dividing it by n minus r factorial. So let's look at another example. How many different ways can a class of 10 students select a class president, a vice president, and a treasurer. So we had 10 people all together. So 10 goes here. And we're trying to determine 3 different roles: president, vice president, and treasurer. So the 3 goes here, okay? So what we're doing is doing 10 perm 3. So that's going to be 10 factorial divided by 10 minus 3 factorial, which is 10 factorial divided by 7 factorial. So what we're going to do is write down 10 times 9 times 8 times 7 factorial. And then we're going to cancel out those 7 factorials. Should we do it? Should we do it? Let's cancel it out. Here we go. So all that's left is 10 times 9 times 8, or 720. Isn't that amazing, Max? In a class of only 10 students, there's 720 different ways that we could vote for a president, a vice president, and a treasurer. That's amazing. Oh, where are you going? You leaving? Okay, peace out. We have one more thing to talk about, though, Max, and it's combinations. I think that maybe you should play with this pen, but don't draw on yourself, okay? There, that's pretty cool. Okay, so combinations. Combinations are like permutations, and they help us figure out how many arrangements can be made out of lots of items. The only difference is with the combination, the order of the items doesn't matter anymore. So, for example, if I have those same 3 letters, A, B, and C, there's only one way I could group all 3 letters. ABC is the same group as BAC. That's the same group as CBA because the 3 letters are the same. The order of those letters doesn't matter. So when we do a combination, looking at our formula, N represents the total number of items. And again, R represents how many items go in each group. The formula is slightly different for a combination because you're going to have N factorial divided by R factorial times N minus R factorial. Some formula sheets will put this R over here on this side of the formula, but it doesn't matter because it's all multiplication. So let's go over a quick example. A teacher is going to select 5 students out of her class of 12 to go on a special field trip. How many different groups of students could go? So it doesn't matter what order the students are chosen if they just get to go on the field trip, right? There's no ranking here. It's just 5 kids go. So if Max and Calvin and Mommy and Daddy and Miss Johnson got to go, that's the same as choosing Miss Johnson first, and then Max, and then Calvin, and then Mommy, and then Daddy. It's the same 5 people. So the order that they're selected doesn't matter now. So we're going to do a combination. So if I want 12 combination 3, I'd have 12 factorial divided by 3 factorial times 12 minus 3 factorial. That simplifies to be 12 factorial over 3 factorial times 9 factorial. And so then what we're going to do is write it out. 12 times 11 times 10 times 9 factorial. My 9 factorials are going to cancel out. And I'm also going to divide out some things here. Maybe I'll divide the 3 into the 12. 3 goes into 12 4 times. And, oh, yeah, those canceled. I'm going to divide the 2 into the 10. 2 goes into 10 5 times. Now, I've already divided everything on the denominator into the numerator. So all that's left is 4 times 11 times 5. So that's 4 times 11. That's 44. And then 44 times 5. I don't know what that is. Let's find out. See if I can get a calculator up here. It's going to think about it. Let's see. Maybe not. 44 times 5 is, let's see, that's 40 times 5. 40 times 5 is 200, and 4 times 5 is 20. So I guess I could do that in my head. It's 220. So if I have 12 students, and I choose 5 of them, there's 220 different groups of 5 students that I could send on that field trip. That's so awesome. Let's clap. Let's clap. Here, put your pen down and clap. Clap for everybody. No, I just want the pen. Yay, Maxwell. Oh, he's got the mouse. Okay, we better end. Peace out, kids.